we are very excited to have this as part of a collaborative. It is a shared high-speed network as well as compute. And I want to call out the high-speed network separate. We will not spend a lot of time talking about this, but this is the Science DMZ piece of this. The way I explain the Science DMZ, for those of you who are not familiar with it, is when you drive in a very large city, DC, Atlanta, etc., there's a high occupancy vehicle lane. The rest of us folks get to travel in the regular lane. But every now and then, if you're very, very special, you get to bypass everybody and go in the high occupancy vehicle lane. The shared Science DMZ is a high occupancy vehicle lane for your research. So what we know on NCCU's campus, and I'll do this just briefly, is that some of the research that's done in BBRI and Bright deal with large data sets, and some of our faculty researchers are still using footballs to take those large data sets from one location to the other. The shared Science DMZ is going to assist us in no longer needing the football. So I'm going to spend more time talking about the compute today, and that's going to be our focus. But I did want to at least let you know that the Science DMZ, which is part of this, there's 2 grants, we'll be talking about more in the future. You see the wonderful partners on this. I've already mentioned Duke and Davidson, who both are playing a critical role in this, but we are very lucky in the state of North Carolina to have MCNC as our research network, and they are a critical partner in this as well. You'll see, and you have been hearing about the Science Foundation grant that we received. Very proud of this. Again, I want to acknowledge the collaboration and the leadership of Duke, and that Duke provides us with project management before the grant and through the grant, which has allowed us to get to places of having something to present to you. There are 2 projects, the Science DMZ and Compute. Again, I mentioned the Science DMZ. This is what they do separately. Compute as a service, what is that going to allow us to do? Again, I said some of this through the email, but this is for many of you on NCCU's campus who are familiar with Eagle Apps, which is our virtualization of applications through VMware. This is research-specific, science-specific, math-specific virtualization that runs not on a Windows platform, right? So this is that. The other thing that's beautiful about the Compute as a Service is that it's federated. And so NCCU can access resources, Davidson can access resources. So we're building something that a lot of times is called a condo model, where different organizations, institutions can buy into the model, and the model grows, which means that the compute capacity gets more and more as we grow. This is what you'll see a little bit of today. Michael will do a little bit, probably not all of this, but we do have something to show today, which is very, very exciting. And then this is some examples of how faculty and researchers have used some of this at Duke. So they have been in this game, and Davidson has been in this game for quite a number of years. So we will be learning from them. And that is the intro. We are at the place of moving forward. We've built it out. And then in the second year, what we're hoping you all will be doing is getting so excited today that several things will happen. One, you're going to use this in the fall for your courses, and in the spring for your courses, and going forward for your courses. And 2, you'll assist us in building a community of practice where we bring in more faculty, but we also reach out to some other minority serving and smaller institutions in North Carolina, so that, again, we're growing not just here at NCCU, but the capacity across our institutions, whether you're a small liberal arts private or a public HBCU or a private minority serving or a public minority serving. So we want to, again, expand this. That's the idea behind the share concept. There's some links there, and we'll provide more of these links in the chat so you can get to them as we move forward. I will pause now and we'll go ahead and start with introductions. So I'm going to list the participants on my screen, and if you don't mind, I will start with our colleagues from the other institutions, giving our faculty here at NCCU just a little bit more time to join. Faculty, just since this is the first time, many of our colleagues, both inside NCCU as well as across the grant, are hearing from you. It would be awesome if you would tell us a little bit about, if you're using Jupyter R or any of the tools that you saw in the email, what you'd like to get out of this, what you know, or if you have any questions before we start the demo. That will help us ensure that we're either meeting those expectations today or that we come back to you, because this will not be the only time we get together. So I will start with Ms. Tracy Futhi from Duke, and then we'll go through the Duke folks and then the Davidson folks and then NCCU.
Hi, I'm Tracy Futhi, Duke University. I am Leah's counterpart here at Duke. I've been the CIO here for about 20 years, and we've been using this kind of an environment at Duke to great effect for the last 6 or 8 years. After some faculty suggested to us, computer labs are great, but nothing changes, and you make them all totally homogeneous at the start of the semester. And then if new versions come out that I want to use or someone else in another course wants to use, there's no way to get at them. And so this was the answer for doing that, something that was virtualized, didn't require an actual computing lab, and students could do it on their laptop and without having to take any time to install things. So we're pretty excited about this and look forward to working with you all.
Thank you, Tracy. Laura.
Good morning. Hello, everyone. My name is Laura Webb. I'm a project manager. I work for Duke, but I am supporting the project overall with all the institutions. Looking forward to talking with you all more today.
Thank you. And Mark.
Hi, I'm Mark McCahill. I'm the system architect at Duke, so I'm the tech guy behind this stuff.
Thank you. Let's see, Michael.
Hi, my name is Michael Blackman. I do research in instructional computing at Davidson College. I work as a facilitator and kind of just help faculty use tools that are there, whether they be for research or instruction. And we'll see today one that's used for both.
Thank you. I'll do the ITS folks from NCCU. Courtney.
Hello, I'm Courtney Nash, Director of Infrastructure, and here to help the faculty members here on NCCU campus.
Thank you. Vernon.
Good morning, everyone. My name is Vernon Samuel. I'm a system admin, and I'm here to provide aid to the NC Share project and help this get off the ground.
Great. Amara.
Hi, my name is Amara Haynes. I'm an information technology student at North Carolina Central University, and I'm here to act as a student worker to help this program.
Thank you. Dr. Ahmed.
Thank you, Leah. My name is Muhammad Ahmed. I'm a professor in mathematics and physics and Dean of College of Health and Sciences, and really excited to use some of these resources, especially the DMZ. I'm involved in research, as you know. NCCU is part of Triangle University's Nuclear Laboratory Consortium, which is part with Duke and NC State and Chapel Hill. And we have to move tremendous amounts of data. We generate about a terabyte or so per every couple of hours at tunnel facilities, and storing them, moving them, analyzing them becomes a challenge. So looking forward to what can we do with high throughput data devices and analysis.
Dr. Williams.
Hey, Leah. Yeah, I'm Kevin Williams. I'm a professor in pharmaceutical sciences at the Broad Institute. So my background is more in drug development. And like Leah said, we do handle a lot of large data sets. We've been involved in global gene expression analysis, high content imaging, text mining, AI and machine learning based drug discovery processes. So we've been doing it ad hoc, so this would be great if we can have a sort of centralized system that we can use both in the lab and for teaching. So excited to hear what we have.
Thank you. Dr. Doherty.
Morning. Yeah, my name is Irene Doherty. I am an epidemiologist statistician at BBRI. And yesterday I was in a similar thing, and it's also called SHARE, funded by NIH. And they have federated data sets, but not all of them. And then I'm also under the gun with RTI's Academy Research something or other to deal with the All of Us data set, which is extremely cumbersome to deal with. So wrapping my head around cloud computing and looking forward to working with people in my family here.
Thank you. Dr. Banks.
Good morning, everyone. I'm Andre Banks, assistant professor in the Department of Social Work. Also responsible for teaching the statistics and research methods there. And so always interested in, data and what's going on, what advancements there are. So very interested and excited about this.
Great. Thank you all so much. Well, without further ado, we have had great build up to this. So Michael, the floor is yours.
I'm going to share my screen here, and I'd like for you guys to kind of play along with me. So if you open up a browser window, we'll go to the same site, and we will.
Any preferred browser or Safari, folks, anything would work?
So preferred would be Chrome. So if you've got Chrome open, I want you to go to cmgr.ncshare.org.
And if not Chrome, folks should try with anything, Michael?
Firefox would be the other one. Safari is not supported with most of these applications, so Safari is unfortunately left out in the cold. Edge is also acceptable because Edge is essentially Chrome at this point. So when you're there, I'm going to have you log in. So in this case, we're using a federated identity provider kind of login. And what you're going to do is you're going to search for NCCU or whatever institution you happen to be at. So if you're at Duke, you'll search for Duke. North Carolina Central University. You'll select that guy. You'll select your institution, and then you will go and just hit select. Sorry about that. Just trying to be fancy. They decided to act weird. So once you've selected your institution, you'll log in. In my case, I'm just going to log in. Regular credentials. Fancy Duo thing. You may not have to, depending on how your institution does authentication. Once that's in, interesting.
So we were able to get in.
You were
Michael,
able to.
just so you know, yes. And because it's a teaching environment faculty, we do not have Duo in front of it at this time. Just so we're approaching this as a teaching opportunity. As we move towards more research-based, we'll discuss as it relates to where the data is stored and all of that. But in the faculty side, we won't put Duo on.
Okay, so I was able to get on as well. And as you can see, this is still in development. So the application is a little bit, has some corners that need to be sort of sanded off and rounded out. But for the most part, what I'd like you to do is to reserve a single container. So you're going to go to reserve a container. You're going to select one. And in particular, I'd like you to select Jupyter. And you should see a little button that says reserve. You'll click reserve, and it will automatically appear under My Reservations. So once you've got the My Reservations set up, I'd like you to go to Jupyter and then click Login. So it's going to refer you, and it's going to take you to a very nice setup, functioning JupyterLab instance with everything pre-installed with a consistent mutable environment, and mutable in the sense that people can essentially modify it to their needs, right? So you can pip install.
Hey, Michael, is it useful at this point to ask how many people have already used Jupyter environments before in a standalone mode as opposed to this kind of containerized environment?
Yes.
I just
So-
wonder, because if I was looking at it, I might be like, okay, what's this? How's this compared to something else I know? And perhaps everybody else knows this and has used it, or perhaps they're like me looking at it and saying, okay, I don't know how this compares to any context I know about.
Okay, so go with Tracy's question. How many of you have actually seen or used Jupyter or Jupyter Lab in any capacity? None? Okay,
Well,
so
I've seen it, but
Dr.
not
Doherty-
used it. And I mean, I know Python, but that's about it.
And Dr. Doherty says she's used a little bit of it with all of us.
Mhm.
I think the name of the.
Yeah,
So-
we are, but not through this.
Okay, so this is exactly what would happen on a desktop. So the only thing that's happening here is that the actual compute resources being used by JupyterLab in the background are not happening on your desktop. It's the exact same kind of workflow and system that you would have if you were just sitting at a desktop and trying to use it. So for those of you not familiar with this particular type of environment, it's very big on the idea of something called literate programming. So that is effectively just a programming environment in which you are self-documenting and you provide comments and explanations for things that you're going to do as you go. So in this case, just do basic imports and go on. But the main and interesting thing about Jupyter is that this entire notebook is, one consistent Python environment. So I just imported OS up here, so I can come back and do OS dot a particular, say, function inside of there, and it's still going to behave and access that particular variable. It's a little bit easier to see if we start naming variables. So for example, if I did var is equal to something, and then I wanted to come back later and do print var, it's pretty easy to see that behind the scenes for all these individual code cells, there's a working Python environment that can be mutated as you go along. And if you've done like large scale data science with machine learning, this is probably the environment that you're familiar with or have seen, just because it's very popular in that sense. So that was just a quick overview of the notebook format for those who haven't seen it. And in addition to just general notebook stuff, you have the ability to do regular Python programming. You can even do C++ programming, things like that is necessary. But the main takeaway here is that you've got a full format that allows you to do, or allows students to do, a report as they're actually coding. So what that means is that you can prepare a document, say something that you want them to run, and they will go through and walk through it and do a basic exercise. So an example of that kind of exercise I can give you. In this case, I prepared a notebook that goes over the 3-body problem. So it's just a basic example of a solver, which just does some cool individual stuff. And from nothing works. Okay. Sorry again. There we go. Everything is still new and we're still working on it. So anyway, I've got open this Git repository, which is a public repository that has all of the exercises and bits I'm going to share with you. I've created a magic link that I'm going to post in chat, and I would like you all to go to that link. So. Can't seem to find. I lost my ability to actually put stuff in chat, so this is even more embarrassing.
And then we can just, what I did is I just dragged one of my previous Python file onto the tab to the left. I mean, that works too, right?
Yeah, that works too. The thing I was going to show you is basically automated deployment. So if you look here in the files, I don't have anything that looks like the Git repository. I go to this link, I log in, it's going to pull in that Git repository automatically. It's going to put me in the right directory, and inside of that directory, I've got my 3-body problem example that I just had in GitHub. So this works as a means for getting exercises out to students and is a very sort of nice way to just get people in front of code and start running and working that way.
So Michael, this also means that you could update the assignment partway through, right? It's not
Exactly.
a one-time thing. It's, oh, I want to add something else to it. You can do that. And if the students go back to the magic link, they'll get the updated version.
Exactly. So if I wanted to, for example, go to that particular example, and I wanted to say, let's add a new file, but I'm not signed in, so I can't do it. But if I wanted to, I could edit this and then essentially go back to that magic link, and it would refresh everything and allow me to actually start working on it. But the point is that we went from a blank JupyterLab instance to something that's populated with things that you can actually work with in a manner that provided you all with a consistent environment where everybody has the same execution environment. So there's no trying to figure out and install our individual pieces and parts for each student. And from there, it just works. And students can go from the first day of class to, or during the first day of class, students can just start programming and work as necessary. So I've been rambling a little bit, so I'm going to ask, are there any questions or prodding that I would definitely prefer?
So when I brought in my simple Python file, I don't get that menu up on top like you have about being able to run the code. How does that happen?
So you need to select a particular kernel. So once you've selected the kernel, you'll come down and you'll select that particular environment for it to run in. Once it's selected, you will now have the ability to run it and go forward. Because without the actual kernel set up and running, it won't give you those options to actually execute.
I see. And it's not allowing me to load. I mean, I'm clicking on the same item on the right, and it gives me a tab for kernel source, but then do I have to type the kernel myself or?
No, you should just be able to find it in the select box, right? So select kernel.
Is there a pop-up that one needs to turn on or off on the browser?
I think it's more likely that it's doesn't think it's a notebook, that it thinks it's just a text file or something like that.
Did you upload a regular Python file?
Yes, that's what I did.
Ah, perfect. Yes. So in that case, it's a little bit different. So notebooks are intended to be interactive and have this kind of interactive compute thing go along with them. So the workflow is going to be a little bit different. If you're actually just using a regular Python file, like here, this should be what you see, right? You
Yes,
see
exactly.
the code there, and you can actually get a sort of stable environment out of that. And in the same way that we distributed out the notebook, we can distribute out the code so that people can go through and work through this example as it goes along.
Right.
So for those straight Python files, what you could do to run it is, and Michael hasn't shown you this yet, but you could open up a terminal pane in JupyterLab and then issue the Python command to run that Python script.
Yes. So
Okay.
in that case, I can actually just show that to you. So terminal here. 3-body problem. I want to just run it. So that's what I'm going to do. I'm going to do Python. Actually, I'm going to find the directory that I'm in, that I need to be in, which is this one. And then I'm just going to run it like a regular Python one. So 3-body. And it's going to do its thing because it expects a particular input that I'm not giving it. It's going to crash, but it's just the same way that you run it. So in addition to this environment's mutable. So if you've got a particular Python package that you need to install, or if your students are working on something extravagant and they want to explore what's possible, you can actually mutate and change the Python runtime environment. So in this case, I'm installing a particular package so that the next time that I open up a Python terminal, I'll have TensorFlow ready. I can do the same thing with PyTorch. I can do the same thing with Anaconda and Mamba. In that way, you are allowed to provide additional, or your students are allowed to explore a little bit more. But under that same vein, you can actually provide an environment that has all the requirements for either your Python file or your RStudio file. So just like we have with JupyterLab, we also have the same kind of environment for RStudio, where you've got an RStudio instance that I've selected and run. So you would have to reserve it first. And then from there, you're taking to that running instance. And inside of that instance, you've got all the familiar RStudio things. So you've got the ability to work with an R Markdown notebook. So in this case, I've got a simple R Markdown notebook set up and I can run it and modify it just as you would expect a regular R Markdown file to be there. And in the same sort of vein, you have the ability to knit as expected. So if you've got an assignment passed out to students in RStudio, you can just have them knit it and then upload a PDF to you. So in the same way that the JupyterLab environment is mutable, so is the RStudio environment. In the RStudio environment, we have the ability to install in particular packages or anything that you might need from CRAN or anything like that, either on the fly when it's actually running or sort of pre-built so that you can just have students ready to go with the packages that they need. And that's sort of the idea behind all of this, is that you provide students with a single uniform environment for them to work in, for them to explore, and for them to play in. And one of the benefits of this is that the compute resources needed to fully sustain this enable sort of compute resources used for research to grow. And there's a nice back and forth sort of partnership that works there. So the more students using the sort of stuff, the more reason there is to actually grow capacity, which means that there's more time and compute for research related projects, which is another side of this that we haven't really talked about yet. So again, I've said a lot.
So I have a question for the faculty. How many of you are doing two things or would need two things? One for your own research and the second for instructional purposes. So, because those, setting up some of the things that Michael's talking about now for instructional purposes, but it sounded like Dr. Ahmed was talking about his own research. So I want to make sure that while we're answering your questions, some of this is how you might set it up for instruction, which may be just a little bit different, not a lot different. Thoughts on that question. And before I let you guys pause for just a minute, Kevin from Davidson has joined us as well. So Kevin, if you would just introduce yourself quickly to our colleagues that are here.
Hey, thanks, Leah. Kevin Davis, I'm the CIO at Davidson. Really glad to be working with Leah and Tracy and Mark and Michael and everyone on this great project. And thank you all for the time today.
So I'm just going to go out on a limb here and say the research component of this is that you're going to use the same environment for research that you do instruction. So you have a path that you can take students through where they go through low-level courses using something like Jupyter or RStudio. They get an initial introduction to the system. From there, they grow and they go do more advanced independent projects. And once they get past that stage where they can actually operate on their own, you can let them sort of see behind the curtain and start using the resources in a research capacity. Now, that pathway has worked out very well at Davidson because we focus on a lot of side projects and instruction, sort of our goal. But that's sort of one of the paths here that there's a partnership between instruction and research. So the fact that you have instruction going on here is sort of what enables capacity for research. And that's where that back and forth comes in.
So it might be useful to mention what we've got for compute capacity right now too.
Yeah.
The back end that the stuff is running on and the motivation for why you'd want to do it a little bit differently is there's a lot more compute than you're going to have in your notebook. There are 4 servers right now. Each of them have 128 cores and 512 gigabytes of RAM and terabytes of storage. So for a student, if they're working with any kind of big data set or something that's fairly computationally intense, this gives them access to more compute power than they've got on their notebook. That's the motivation besides the standardization for why you'd want to do a course with this or use it for research.
Yes. Thank you. I kind of got lost in what I was saying. Thank you for pointing that out. But that kind of point enables that natural progression, right? Where you go from instruction for low-level courses to medium courses to sort of senior year courses and senior thesis projects to graduate level instruction and graduate level work where people can and will use a ton of resources. You have the ability to scale these individual pieces up or these individual instances up just because of the nature of the way that they are there. So for example, we could set it up so that say one Jupyter Lab instance has 20 cores or 30 cores or however much memory that you would need for your computational work to happen on. And as you saw, I think when I installed TensorFlow, we have access to that Science DMZ connection. So we can pull in tons and tons of data in a really fast manner. I think we just did, what was that? 200 gigabytes or 200 megabytes was our download speed. So.
And remember, all this compute is happening at MCNC, so you're not needing to download, if you will, that data here to NCCU. Again, you're working all the compute. So part of that for Dr. Williams, Dr. Ahmed, well, actually everybody that mentioned large data sets, getting the data sets there, right? And then you yourself from a research perspective, as well as your students would then have access to that resource. And the beauty is you're seeing you can access those resources here. We know we're all in different locations across the state right now, or maybe even outside the state. So this gives your students and your research colleagues the ability to access more anywhere.
And you've got access.
If you can drive that
I-
home enough.
Michael, I've not been able to execute the way you are running your Python code. So I mean, I got the code, looks just like yours.
Mhm.
And I go and I right click and I say create console for editor. And when I do that, it creates a little console. But
So
You want to do a share screen? Do you want to let Dr. Ahmed do
Yeah.
a share screen and then we can walk him through?
so I've
That's
lost.
a great example.
I've lost my Zoom toolbar, which is why I couldn't share something to chat. So if you could make me not share or stop me from sharing.
Oh, okay.
and
Let me see if I,
actually- I can't actually make it go away. Because it's
Oh.
hidden for some reason on my screen.
okay,
Thank you.
of course.
yeah, I'm just gonna share my entire desktop so everybody can see everything else happening. Um, uh, can you all see my very confusing desktop here?
Yes.
Yes.
Okay, so let me close this up. So now I just got a very small Python code. And when I right click and says create console for editor,
Mhm.
did that. And it doesn't give me a console prompt where I can actually just run the code.
Right. So what you've done is you've opened up a Python instance running in the background that provides an environment for that code file. So this enables things like command completion and some other cool little features in the editor that aren't normally there without that console running. This is not what you want to actually run or execute the code with. So if you close out that guy and you see the little plus next to the X up there next to your window,
Yep,
click on that. Scroll to the bottom.
and just
Terminal.
run that terminal.
Yep.
Okay,
That is what you want. And
all right. So
if you grab onto that tab, you can actually move it so that it's half in the screen.
like,
So- Yeah,
nope.
so grab it and pull it into the middle. Yep, like that. There you go.
Okay. Oh no, so now I can just run it normal.
Yep.
And I can just run, calc properties.
Um,
So now it needs a full path to. I have now loaded it up. I moved the file over up here.
Mhm.
So I guess does it know the full path to it or?
Yes, so you're currently in the work directory, which is your basic home directory. So it will be able to autocomplete that path. So if you backspace the full and just do /full tab, you just hit tab when you do it. It should autocomplete.
Okay,
There you go. So you can type full autocomplete just like normal, and then let it run.
okay, I forgot to give it other things. Is there a way to do a control Z on C on that? Yeah, okay,
Yeah, it's a regular terminal, so it's a proper Linux terminal.
okay, all right. All right, that way, okay, now I know what to do. Okay,
So I
Super.
just put a link in your chat. Was the link that I meant for everybody to have earlier when I lost my Zoom window.
Okay.
So that link will take you to that 3-body example, and that notebook will be in that folder. And what it's going to do is it's going to automatically download that stuff for you, and you'll have it there in a way to actually access and work with.
So from a persistence perspective, if a student, and Michael, I know we had this conversation on our pre-planning call, but I want to ask it again, just in case. Again, this is part of the planning for the fall. This is, as you said, we're still growing this environment. But if I wanted to create something for my students and have it ready, I would create it and then send them have the link prepared. Is there something that I can do to have all of them? And this may be, Mark, a question for you, where as a faculty member, can I create an environment, and I won't use the right language, and assign it to a set of students, or have the students get that particular container or environment, whatever that is?
Yeah, what we do a lot at Duke is set up course-specific containers. What I've given you here are the generic Jupyter and RStudio, because that's a good place to start. But a really common thing to do is to say, well, we're teaching this flavor of statistics class, and it's going to want to have a different set of packages that get updated through the semester that'll conflict with some other instructor stuff. So we make a different kind of container potentially for each class, give the faculty access to update the container if they want. And that also makes it possible to pre-stage like data sets, so they don't have to wait for them to download, or have the assignments in place to start with. So usually what I suggest is, if you're thinking about doing this for a class, put together a rough idea of what the class assignments are going to look like. Make sure that the packages you need are there. If they're not, then you work with us to make sure there's a new container flavor where you can have extra packages. The last thing that I beg faculty to do is, since we're trying to size the containers so that they don't use extra compute that somebody else could use for research, if we know what the hardest project is going to be and can run that, then we can say, okay, if we make the container this big, it'll comfortably run the worst case assignment. If we don't have that, then we make a guess, but we might guess wrong. So it's nice if we have the worst case assignment in hand too.
And I'm just going to throw in there, when he's saying container, he's saying execution environment. So the environment that you're running, sort of this stuff that you would have at the terminal, or the available commands and things like that. You have complete
So how do I ensure as a faculty member that my students don't see everybody's stuff and they only see the stuff that I want them? You know, they can see the generic, right? The open resources, if you will, but then I want them to see my courses specifically. I mean, I know how we do that inside the virtual environment here, but I don't know how we would do that there.
So you're saying you want to make sure the students don't see course containers or course environments for courses they're not enrolled in? Is that what?
I guess if every course is listed as a course, then that would be, you know, you log into my course, but we may not want students in other faculty courses, right? So,
right. So one way of handling that is to if we know up front who's going to be taking the course, then we can restrict what's available for a reservation to only those people who are taking the course.
Okay.
Another way of handling it is that you can construct a magic URL that you could put in the course syllabus that the student clicks on, and they don't even see the reservation part. They just go directly to their instance of the course container.
So put that in Canvas, if you will.
Yeah, that's in some ways the simplest for the student, because they don't have to go and pick from a list. Instead, it's just click on this thing. If you haven't ever been to the containers yet, it will make one for you. That's your personal one. After that's happened, every time you click, you end up in your personal container and you don't have to look at reservation lists.
Thank you.
I'll add that that's been at Davidson, that's been sort of the main way that we do courses with this sort of environment.
Put it inside Canvas.
Yeah, or actually inside Moodle, because we don't have Canvas. But speaking of that, there are also automatic grading options for these kind of things. So if you're doing assignments in R Markdown Studio or R Markdown files, or you're doing them in Jupyter Notebooks or in Python, and you have access to Gradescope, for example, you can set up automated grading pipelines for these types of assignments. And there are a few tools that integrate with the kind of things that are inside of the NC Share Compute as a Service that allow you to design assignments to be automatically graded and to set up that sort of environment. Which, as you get
faculty, I'm sorry. So faculty, this is your time. What kinds of questions do you have? Given what you've been able to see, I know that this is a very high level, very fast overview, but one, we're considering offering more in-depth training on the creation and utilization. So you can use it this fall. Is that something of interest? And then what would you want to make sure was included in that workshop, if you will, for this?
I'll start, because first, I don't teach any courses. I'm a research scientist, but the direct access to the container, if I'm saying this all correctly, would be important if I'm using, confidential data in a research study. So, sometimes step one is stripping off the consent form names or something, but I wouldn't want anybody to see any of that. So that's one thing. The second thing is all the other things that I've had to deal with is billing. Is this going to cost us anything? Okay, that's it.
There is a grant. This is funded by the grant. And so that's where we are. We have the grant through 24 and the equipment is paid for. So and we need to replace that. We're good. And we hope to continue to expand the, Dr. Doherty, I mentioned the condo model. So the more institutions we have interest in this, and the more opportunity there is for this being, I'm going to say, a shared service, which might mean we go to Dr. Kumar, who's not here, and say, this is something that we want to be available to all our research, both teaching and true research faculty. How can we ensure that there is some democratization to a solution like this? And so that would be Dr. Kumar and Leah's responsibility to identify those. We might be hitting on some doors just for some funding where you might buy compute elsewhere, right? But that's to be determined in the coming years. Great
So,
question,
Leah,
Dr. Doherty.
I can think of one possible use is, we are in the process of recurriculuming our PhD program for INBS. And one of the things we want to start we want to bring biostats and statistics in the first semester offering this fall. And which will have components from, epidemiology and statistics and other things. So I can see, gearing up during summer, whoever is going to teach that course to use something like this. It's easier to start something new with little bit advanced students. I would rather try this with incoming PhD class rather than incoming freshman class. But it may have its own, merits as who is a clean slate learner, right? I mean, freshmen may be able to just absorb this much faster and quicker just because they don't have anything on their minds. But yes, I can certainly use this as a tool. By the way, a quick question. So when I ran it in the environment you asked me to run it, what happens to figures and things like that? It didn't pop out any figures or things like that for me. Do I need to run it in some sort of a interactive mode or something like this?
So depending on
mode?
how you've actually written the code, it has a bunch of different options. So there's a sort of desktop environment that you can run this in if you're doing sort of an old style, pull up the figures as you come, kind of like a MATLAB style, create figures in that capacity. If you're used to that, there is actually a desktop environment that can be hooked into this that would allow you to see those and work with those.
So by default, they don't show up. So I'm going to share my Firefox screen again. So can you see my screen now?
Yeah.
Right. So I mean, this was my code, and it was old style many years ago, Python code. Just PLT figures and things like that.
Yeah. So if you do Control A and just copy all of water.py.
Oh, okay.
Yeah.
Yep.
Copy it. Now you're going to do plus. And you're going to go to Python 3. You're going to click on that one. Inside of that code cell, you're going to paste your code. And now you're going to hit Shift Enter. So if you scroll down, the plots and stuff will actually show. But it has to be inside of that notebook environment in order for it to happen. Because that's the only place where you've got, like, this is a think of it like a web page, right? So you have to have different little segments and components for this to work. So you've got the code cell, which has the actual code, and then a second component to it laid down there at the bottom, which is going to be all your figures.
Okay, so what I've learned this far, that the best thing to do it is to be in this environment.
Mhm.
Okay, got it.
Yeah,
Thank
and
you.
this is why we think using notebooks is so important from both an instructional and a research perspective. I mean, from an instructional perspective, students can write their code, see the visualization of the outcome, and then pass all that along as the work product, right? Here's my code and proof the code worked. From research, we know reproducibility is always a growing question. You may have questions of students working in your labs, them doing work and being able to show their work and see the output analysis is a real strength of this. And then, of course, because you essentially have the source code of their code plus the images where you can print them PDF, as Michael noted, there's an easy way to store those kind of interim works and milestones as you go along.
But getting back to the research focus, which I think Irene was asking about, since she's research faculty, we can set up the environment that makes it comfortable for you to work, right? So it's possible to build or set up an execution environment that just enables your work and enables sort of the download and anonymization of the kind of data that you want. And
Yeah, the one thing that I just kind of chatted with Leah about that I'm thinking of is we have this grant right now. It's practice-based research networks, where you guys know what that is. I don't know. It's like taking clinical, little clinics here and there and bringing them all together to do research. So the plan for this year is to come up with a plan. The aim for this year is to come up with a plan to build this data warehouse where you're combining EHR, electronic health data from like all over the state. So that would make things a lot easier for people to access to do research. That's what I'm thinking long term. I sort of know what Dr. Kumar does around here, so that might be a thing. Not sure, but.
I don't know about that explicitly, but the capacity to connect to your data warehouse and actually pull in and process stuff would be something that you could absolutely do in the RStudio container or the RStudio environment as a sort of common through RStudio.
Right, that I know how to do, kind of. So, but I will keep this in the back of my mind for what I'm doing on that project.
And Dr. Doherty, it may be that we, sit down and actually diagram out some of those, your use case, your processes, and then we can ensure, you heard Mark mention the capacity for storage and compute available. So it is a matter of, and I know you have confidentiality security as an issue that you want to make sure we're protecting. And so I had made a note that we need to follow up on all of that. So I think that these are the kinds of questions we want to have come forward. So you're exactly asking what we need to hear so we can build out, not just for, and I don't mean to say not just for instruction, not that that's not one of our core business, but that we here, as well as Davidson's growing their research, that we have a whole nother segment of straight up hard research going on. And we need to make sure we're providing for that as well. And that's why partnering with Duke is so valuable.
And so implicit in a lot of this discussion about research and computing is the notion that eventually the compute as a service would grow to a capacity required to a state where it can be something called a condo model computer. And that capacity, like small schools like Davidson could buy in to compute nodes, which would then enable access and resources for everybody else attached to the system. Whereas people at Davidson would get first pick of it, but when they're idle, everybody else comes in and goes. And I can just say that, the amount of compute resources we have at Davidson would very much be happy in that kind of environment where they can be used for proper research and things like that.
Right. So Leah, I think that we might need to loop you in on this stuff because we don't get the funding to do the second part of the studies, NIH, unless we have this plan in place. And if you can figure out part of this plan, that might be good. So we could have a conversation offline with Dr. Kumar about it at some point.
And
soon.
I would definitely want to bring in my colleagues from, if not both Davidson and Duke, who is already doing this, to make sure that whatever you're asking is speaking to those that have provided it. So we're sure that we're answering your questions properly. I am the first to say that I am learning from you, from Davidson and from Duke, that my own stack of knowledge is not this high-end compute. So I definitely need to include colleagues, but want to get that done. Thank you, Dr. Doherty.
Sure.
I see that we're at 11:30. We have recorded this, so those of you that have colleagues that have not attended, I will send out the recording as well as the link directly to the logging in. Please, feel free to share that. It is open. It wasn't just open to you all. It is open. So get in there and kick the tires, ask questions. If I could just ask a quick virtual or real raise of hands in interest for workshops potentially this summer. And I know summer is terrible to say that, but maybe even this summer.
Yeah, I think for our lab, for sure, Leah, we need to think about how we can use this, maybe for some of the AlphaFold work we're doing as well.
Great. So maybe what we want to do is set up some one-offs with some of you that attended, and then those of you that raised your hands will set up a one-off to make sure that we're providing you what you need, and it may be training specific for your area, right? We may not be able to do a wholesale training like we envision. It may be here's how you're going to use it for your specific stuff, especially if you're doing research versus instruction. And we'll go through it that way. So I'll take those as action items to delegate to Amara. So Amara, she said she's a student. I've been working with Amara on several projects around digital equity for the last 3 years. And she is a graduating senior in December. Sorry, I graduated you early, but I've asked her to assist in this because one of her background, her ability to pick things up, and my confidence in her. So you'll be hearing from she or I or Vernon, who is a permanent IT staff member who started, you may know him, he started working in the library, then he started doing desktop support, and now he's on the server team. And so he is been doing great things, and just excited for both of them to be able to be here to support us and support you.
And Leah, thank you so much, and everybody. It's limited time I've got to explore it. It really is already a step ahead in the way we do things up here. The last time I taught Python was 4 years ago for my computational physics course, and at that point, even it becomes a little bit of struggle to have 10, 14 students in the class and them all working their laptops and have the environments right and the imports right, and pip installing this or that or packages. This common platform provides a space that they could be anywhere. All they need is a browser to make things work. And then I would love to catch up later on to figure out how does the transport of data happens across all of this, right? If I have a data sitting somewhere on my disk, how do I move around that data sets to an environment where it is available in this, virtual machine environment, so that I have access to it, and I can have a good throughput from wherever I'm producing data to this space.
So I will do just a really high level. You won't necessarily be able to do your large data set push from anywhere. You have to be near a high occupancy vehicle lane. And when you drive down the interstate, high occupancy vehicle lanes aren't everywhere. So we are being very intentional about where we pull those. BBRI and Bright are specific to those locations, and Courtney is working with MCNC on that development. Once you're inside MCNC, everything's a high occupancy vehicle lane. We are trying to get the NCCU to MCNC connection. So more to come on that. Hopefully that explained it in my terminology. But that doesn't mean that we can't work with you, Dr. Ahmed, to get your large data sets there. I do want to follow up, Mark, with you probably around security for the hard science research that's going to be done there, and what can we do to protect, ensure all those things.
Yeah, and you talked a little bit about sustainability, Leah, I think beyond 2024. So
oh yes,
the plans for that will be good.
Sure.
Thanks.
Yeah.
Of course.
Well,
Thank
the
you.
initiative and some of the things like the resources we have for training and documentation and support are only through that time period. And you know, there may or may not be a zero cost extension for one more year, just time wise for the project. The equipment is brand new. In fact, with shipping delays, one of the reasons we even talked about extensions is that, you know, from the time we ordered it to the time it actually was here on the ground was the better part of a year. So it took a while for the hardware to come in. But you know, these servers have a lifespan significantly longer than the grant. And Leah and I are committed to continuing to partner our institutions to support this through the life of the hardware at least. You know, I think, you know, Davidson, NC Central, Campbell, you know, there's so many institutions out there in the state who are not big enough to have large research computing programs, but we all have research computing needs. And I think Leah and I are committed that if we find ways to work together and partner on this for things we can all use, we're really excited to try and help support the faculty across our institutions.
100%.
I just want to add that computational physics was the first course we ran on the sort of centralized Jupyter. Just Hamid's comment. I wanted to point that
Thank
out.
you. All right. I'm the one that sent the invite, and we'll send follow-up emails. So if you have anything that you would like to follow up with me directly, let me know, or I can connect you with the appropriate parties. I do have some takeaways, and I'm sure Laura has kept track of all my takeaways as well, to make sure that we are documenting it all, not just for NCCU, but for the grant, right? We need to make sure that NSF is aware of all these awesome things that we're doing. So thank you all again so much. I hope you are able to enjoy this beautiful spring day, and you'll hear from us again. It will be in the next couple of weeks. I know that those of you that are teaching faculty will be in the midst of exams and graduation, but I still will want to communicate with you, just so you don't feel like I fell off the face of the earth. Keep the momentum going.
Thanks, Leah. Thanks, everyone.
Thank you all so much.
This is great.
Thank you.
Thank you.
Have a good one, everyone.